actually created to be like the ultimate SigMF tool. As far as companies using it who are kind of public about it, Muon Space is doing some awesome stuff, bringing raw RF from orbit down to the ground, using SigMF for the metadata, DeepSig, Airbus, and then I found recently this open source threat intelligence tool called MISP supports it. And then MATLAB does have a SigMF function, but unfortunately it's like the sigmoidal member function. It has nothing to do with SigMF. So, yeah. Now that being said, if you're in any language, you can always read in a binary file, like with NumPy, you can do from file, as long as you know the data type. Pretty much every language has a way to read in JSON, so you don't need your language or your framework to really support SigMF in order to create or read in recordings. And this is kind of the, it's not a minimal example. The minimal SigMF metadata would be like just sample rate data type. But this is kind of a short example of what a metadata file might look like. So we have the global section where you have fields that are common to the whole recording. So sample rate. Now with SigMF, we don't support changing the sample rate in a single file. If you have information about the hardware that was used to record it, or whatever you want, there's additional fields besides what I show here for global. And then captures is meant for when your frequency changes mid-recording or you stop and start the recording for disjoint time. That's how you would record that in the metadata. See, the captures is an array, and you would just add new items every time you either change your frequency or start and stop. And once again, there's extra fields that aren't shown here, like geolocation and stuff. Now, annotations is how you would mark up a recording, kind of like adding a comment to code. They're essentially, each annotation is a bounding box in time and frequency, and you can put a label on it, you can put a larger description, and you don't actually need the, I think the frequency is optional, right? Yeah, but I typically, I always use both the time and the frequency domain when I'm adding an annotation. Now, as far as the data type, as you may know, binary IQ files, or the samples coming out of your SDR, could be floats, integers. This is SigMF's kind of key for how the data type field is formulated. And this is actually not the entire set, but it's the common ones for complex samples. SigMF also supports real samples if you're doing direct sampling or anything like that. But these are the most common data types that you'll see. Now, as far as where to find the specs, that's one thing that's kind of changed, because in the past there was a single markdown file in our repo that would have the specs and a bunch of description around it. But in the past year, we moved things because we started refining our JSON schema, which a lot of folks requested. And we realized we don't want information in two places. So now we have everything living in the JSON schema, like both the actual schema and the description of each field. And the specs is now rendered from that schema, as well as a little markdown file with some introductory text. And we render both an HTML and a PDF from that schema. The HTML is what we host at sigmf.org. And then the PDF can also be found. I think there's a link to it on the GitHub repo. And yeah, I mean, it's nice as far as maintaining the specs now. Everything lives in one spot. And we can really work on refining the JSON schema that a lot of the software folks focus on. So I mentioned there's the core SigMF specs, but there's also a group of kind of extensions that live in the main repo. Maybe calling them core extensions is misleading, but there's kind of refined extensions, and I have a list at the top right here. So for example, if you are trying to add like GeoJSON, like lat-lon to your either your receiver or an annotation, there's the spatial extension. Yeah, and then we also have a community this is actually pretty new. We have this community extensions repo, and that's where you would sort of propose a new extension, or maybe if you're using one internally, like at your company, and you think it would be useful for other people, you could make a PR in the community extensions. And then if we find that a lot of people are using the same extension, we have a process for moving it into the core, the main repo. But we do want it to be used by at least more than one group by the time it moves to the core, the main repo, because even if your extension's awesome and perfect for what you're doing, if it doesn't really apply to other people, if it's too specific to what you're doing, then there's no real notion of like software interoperability, because other software is not going to implement and use those fields. So you're free to keep using the extension yourself, but there's no point of making it this big main extension. Okay, so as far as GNU Radio goes, we currently have the minimal blocks, which is the most basic SigMF functionality you can imagine. They're pretty much just wrappers around file source, file sync. We added them a while ago just to get something in GNU Radio, and I'm glad we did, because when we lock down like Ubuntu's release every 2 years, it's nice to have something like this. But in the long term, we really want a full GR SigMF. Now, the other kind of out-of-tree module that you might want to look at if you're doing a lot of SigMF in GNU Radio is Jacob Gilbert's utility here. It includes a lot more functionality, like actually adding metadata as stream tags, and in reverse, making metadata out of stream tags. The actual file source block has like type conversions, which the minimal blocks don't have. You have to specify the type, I believe, when you use the minimal block. And by the way, I forgot to mention, Jacob Gilbert and myself are sort of leading the SigMF like leadership, I guess, within the GNU Radio organization. But there are a lot of folks involved. Now, there's also our Python package. So separate from GNU Radio, if you're working in Python, you have the option of using our SigMF package, which lives in our main organization. It can read SigMF, create recordings, and it has a validator that uses the schema to validate your SigMF metadata. It has a lot of functionality. It can deal with collections and archives. And a huge thanks to Kyle, who maintains that repo. But there are many contributors. As far as collections and archives, this is a part of SigMF that some folks may not be as familiar with. So if you have a bunch of recordings and you want to logically group them, in this example, it might be hard to see, but I've got 4 recordings, which means there's 8 files total. There's the data and meta for each one. What you can do is create this .sigmf collection file. And it's essentially just a quick way to say that all these go together. Now, this is different from archiving. So when you make an archive, that's tarring all these files. And that's what we call a SigMF archive. It does not include compression. Right, a .tar does not actually add the compression. If you want to add compression yourself, you can choose whatever you want. SigMF doesn't really specify that, and we get that question quite a bit. And that's called an archive. Now, as far as updates over the last year, so version 1.2 was released earlier this year. There actually weren't a ton of changes to the core spec. We added a UUID to the annotations object. There were some tweaks to the spatial extension, but mainly we were improving language and making it easier for people to understand when reading the specs for the first time. And we're now also officially recommending collections as sort of the go-to method when you have multi-channel recordings. So if you're doing any sort of like array processing, whether 2 or more receive channels at the same time, some folks in the past had been using num channels, which was originally added more for like not as much RF related reasons. But now our recommendation is to use collections where each channel is a separate recording. And that way you have a lot of ability to load those files into all sorts of software, because each one is a single IQ file. There's no interleaving of channels, which like most software doesn't really support that out of the box. Now, the downside is you have a lot of files. So if you have like a 16-channel receiver, now you've got 32 or 33 files, and that's where the archives come in. You can tar them into a single file, make an archive out of it. As far as next steps for the project, so SigMF.org now has our HTML-generated specs, but there's no landing page yet, so we're going to look into making one. The closest thing, other than the README, the GitHub README, would be iqengine.org/SigMF is kind of like a one-stop place to go for all the SigMF resources. It includes a learn SigMF in 5 minutes sort of read-through with some examples. Another thing we need to do at some point is actually make JSON schemas for all of the extensions. That way they can get included in the rendered documentation. There were some ideas for a VS Code extension. There was one in the wild, but it really only did validation with the schema. So there's some ideas there for like graphically being able to edit the metadata. And then we're hoping to get our Wikipedia page approved soon. And by the way, we're actually not, we sort of moved away from using SigMF as an acronym. Initially, it stood for signal metadata format, I think. But now we're sort of just trying to call it SigMF, like you see here. And yeah, but we're in a pretty stable state, so that's why there hasn't been a ton of changes. And more folks are using it each year, and we highly recommend it. If you're using binary IQ files already, it's a very, very tiny step to start using SigMF. You don't need any software. You can just open up a notepad file and manually fill in the JSON. There's a bunch of examples on the README and on IQ Engine with example metadata that you can copy paste and then just change the fields you're interested in. So it's not a huge leap, especially if you only have a few recordings. And with that, in order to get back on schedule, I'll ask that any questions be directed to the SigMF channel on Matrix, which is where we have discussions. And I'll go ahead and give it over to the next speaker. Thank you.